All right, the third step or third piece of the assignment is down here, and it says once the wall section is determined along with the R values, you're going to produce a heat load calculation for the house. Given below is the attached heat load worksheet. Assume that there's a finished ceiling at 8 foot. And so this is the worksheet for the design minimum annual heat loads that we're calculating for this small little residence. And in the materials that I've given you, there is kind of a guideline to follow those steps. So the numbers here, in terms of the line numbers, we're going to kind of look at here and how that correlates to this. So line number 1, if you have an unheated attic, get the R value. So we're looking at figuring out what the ceiling area is underneath our attic. So in our small little project here, you have a little 30 by 40. And that gives us an area of 1,200 square feet. And we're going to assume that for this little house here, that there's either wood truss or something in here for this residence. So when you're calculating that ceiling zone, you're calculating it as though it has a flat ceiling. It would be a different calculation if you were doing a cathedral ceiling on the inside. And if that's the case, you would use line 2 where it says cathedral ceiling. So the area that you have is here. And then you're going to plug in what your R value would be for your ceiling. So right here where it says ceiling R value, you know it's going to need, according to what you have to get, it's going to be at least 38 or greater, right? Because in the first part of the assignment, we know we're targeting an R value of 38. So you will plug in whatever value you calculate for that space. You take the area, divide it by that number, and then you're going to get a value. And then, unless you did a cathedral ceiling, we can cross that out. The exterior walls here are numbered. So if you have a house where you have one material on the front of it and another material on the side, so let's say you had brick on the front and vinyl on the other 3 sides, then you would calculate this as having one R value and this side as having another R value. We're going to assume that we have the same materials all the way around the exterior of this residence. So we have one wall that is 30 feet by 8 feet. And that gives us a value. And we're going to multiply that by 2, right? Because we have 2 opposing sides. Then we would have 40 feet times 8. And that's going to give us another value that we're going to multiply times that. And that gives us the total area for the exterior. So there's a value there. But what happens are that you have these openings that occur along this exterior, and you have to subtract out or calculate a different R value for those window areas and door areas than what you would for the solid wall section here. So in that case, it tells us we have 8 windows that are 84 square feet. So you would take that total and subtract the 84. And then we have the door, which is equivalent to 40 square feet. So you would subtract out that 40 square feet. And that gives us ultimately the total area minus the windows. And that value here is the one that would plug into the exterior wall here. So you would plug in that area and then whatever your R value. So in the case of what I did, I had an R value of 21.57, I would divide that and come up with a value. And you could do it for each of the 4 walls. That would be fine. Or in this case, because we know the exterior materials are the same, you can do it as one line item here. The exterior door, if we go back to this table here, so we've talked about line 1 and line 2 and line 3. Line 4, it says the area of most exterior doors is 20 square feet. In this case, we had 2. Use R2 for a solid wood door and R3 for a door, a wood door plus a storm door, and an R6 for an insulated door. And so you can choose any one of those exterior door values that you want. We know that that exterior door is 40 square feet. And we then plug in whatever R value it is you're going to use for that, and we get another value here. For the window type, again, we're going to look at, on this table, for line 5, it says the window area is the area of the sash, so we're going to use R1 for single glazing, R2 for double glazing, would be R3 for triple low E glazing, and R4 for heat mirror. And so most residential projects are double glazed windows, so I would use an R2, but technically you could use any one of those. So we know in this case we're just using all of the windows as the same window type, so we would have 84 square feet, and then whichever R value you select, and then so you take that 84, divide by that value, and then we're going to get what our total is here. We do not have a floor over a crawl space or a slab on grade. We do have a rim joist condition. And so for the rim joist, it is this band that runs all the way around the perimeter, which in our case is this zone right here. That would be the R value. And you can see in this that there is a difference in the material in that section. So we have to calculate that section differently because of how it's framed here at that condition.